the trig ratios. And of course, it's all to do with the right angle triangle. That's what we start off with. And naming each of these sides when we refer to a particular angle. Well, the hypotenuse is always the hypotenuse, of course. But then we refer to a particular angle and we get very creative with our names. Opposite is the one across from it. Ooh, opposite. And the one next to it we call adjacent. Amazing. And we have our ratio. Of course, these are three-letter abbreviations of the ratio. It's actually sine, cosine, and tangent. But opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. We also have the reciprocal ratios. Reciprocal ratios there. Now the reason we have those, because when we are raising trig to a power, we normally put the angle with the trig. So for instance, sine squared I would write like that, sine squared theta. Now the problem then comes with, if I didn't have the reciprocal ratios and I want to write it as a power, and that power would be -1, I would then write that. However, that is the notation for the inverse sine function. So we don't get confused, we have these reciprocal ratios. So that's why we have them. So cosecant, secant, and cotangent. I always think it's unfortunate how they've done it. I mean, to me, logically, wouldn't you have gone cosec with cos? No, why do that? Let's make life interesting, and we'll call that one sec and that one cosec. Whoever came up with it, don't know why they did it that way. But anyway, they're our reciprocal ratios. They start with the very basics. So if I've got sine x then is the cosine of 25, I can very simply say, well, hang on, I know cosine is the complement. That's what the co stands for in cosine, etc. Complement, because they're complementary angles. Complementary angles add up to 90 degrees. So therefore x must be the complement of 25. So 65. Equation like this then, I know, well, hang on, if one is the complement of the other, then they must add up to be 90. And so I can solve that equation. I'll get x equals 40. There's pretty much only 3 questions you could get with right angle triangle trig. You could be finding a side like this. And when we set up the trig equation, the a is on the top of the fraction. So what we're trying to find is on the top. In that case, I would multiply by the denominator and get an answer. The other situation I could have is something like this. It's the hypotenuse I'm finding, but now the pronumeral is on the bottom of the fraction. Okay? I would solve that. So when it's on the bottom, I would divide by the trig. When it's on the top, I multiply by the trig. The third situation is when we're finding the angle itself. So that one there, cosine ratio is 10 on 14. And there's that inverse function notation I was talking about. So we're finding the angle. I want to go back. I want to return it to the angle. So I use the inverse function of cos. And that gives us 44 degrees 25. There are particular ratios which we use that we call the exact ones that we are interested in. And where do they come from? I've got this lovely triangle here. It's an equilateral triangle and all the sides are of length 2. If I chop that in half, I end up with the 30-60 triangle. Bit of Pythagoras, I can see the height is √3, and then I can read off all of those trig ratios I'm interested in. So the sine of 30 is a half, the cosine of 30, √3 on 2, and tan 31 on √3. And 60 degrees, noticing, look, oh there, the complementary ones are the same. Look, sine 30 is the same as cos 60, and sine 60 is the same as cos 30, the complementary ratios. And the other ones we're interested in is 45. So that's going to be an isosceles triangle. Both angles are 45 then. I'll make the sides 1, hypotenuse is √2, and we can read off those. Because if I can't remember what they are, I think of the triangle. But another interesting way of doing it is like this. A little table here, we've got 0, 30, 45, 60, 90. They're the ones we're interested in. The sine is the square root of 0 on 2, then the square root of 1 on 2, the square root of 2 on 2, then the square root of 3 on 2, then the square root of 4 on 2. That will give you the answer to all of those ratios each time. Cosine then reads backwards because they're the complement. And tan, well, we know tan is sine divided by cos. The denominators are the same, so that's nice. So I'm just looking at the numerators of each. So we get √0 on √4, √1 on √3, and so on and so on and so on. It's just another way of remembering the ratios. Measuring angles then. We're going to have a lot of questions involving angles, things we talk about, angles of elevation. As the name suggests, elevate means to lift or to rise. So it's the angle we lift from the horizontal. So that one there, what we would say is the elevation of B from A. That's the elevation of something we're looking at from where we're standing, if you like. So of B from A. It has a matching thing called the angle of depression. That's when you're looking down at something. And that would be the angle of elevation of X, that's what I'm looking at, from Y, that's where I'd be standing. They will always equal each other, because basically you've got alternate angles with parallel lines. So your angle of elevation is always equal to the angle of depression. Compass bearings are other things we look at, and of course our standard ones, north, east, south, west. And then we can divide that in half, and we say, well, north, east, south, east, and so on. So we start at the vertical ones. We think of those as the main ones, and then which direction have you gone? I've gone to the east direction, or I've gone to the west direction, and so on. And you could divide those up again, and you go, which one's the more main? Well, again, the first one, the more main one would be north, and I'm going towards the northeast, so it becomes north-northeast. Whereas the next one, the more main one would be the east one, and then you're going towards the northeast, so it's east, northeast, and so on. I mean, you could keep going if you wanted to. I mean, theoretically, if you went halfway between, let's just pick two. Let's say we're going halfway between southwest and south-southwest. Well, the more main one would be the southwest, and you go, well, that's southwest, south-southwest. But it starts getting ridiculous at that point, so we tend to then use true bearings. And with that one, you always start north and you say how far I've gone clockwise. So there's X to Y. What is the bearing of Y from X? So I'm looking at Y from X. So I put a compass there. I know that's 30 degrees. So I can say, well, the bearing is 120 degrees. If I started at north, went around, we've gone around 120 degrees. Sometimes people put T there to say, oh, it's a true bearing. I guess the other main thing is bearings are always 3 digits. So if it was less than 100, you'd put a 0 in the first spot. You could still use the southeast and so on, and just say, well, how many degrees have I gone in that direction? So, okay, that's south, and I've gone 60 degrees towards the east. You could do it that way as well. If I was the other way around, and say I wanted the bearing of X from Y then, that one would be 300 degrees, start at north, go around clockwise, or north 60 degrees west. You'll notice I just said pick some for these ones. Really, these first ones are just, hey, do you know how to use your calculator? So, just pick some. If you're happy you know how to use them, you know how to use them.